Hello friends, good morning. Dear friends, we were discussing the moment distribution method. So let's continue moment distribution method and how to draw BMD using moment distribution method. So friends, the previous question we were discussing in the last class, that was we calculated end moments MAB. For example, this is minus 129.9. Let us take 130. So this was minus means anti-cloak. This is anti-cloak. Plus means cloak. Minus means anti-cloak. Plus means cloak. And this portion BMD is already known. For this portion BMD is like this, minus 40. Right? So we draw BMD of these two spans. Look, first of all we will draw simply supported BMD, which will be positive WL square by 8. W means 20 into 8 square by 8. This value will be 160. Now we will draw end moments. These end moments both hit the beam from bottom, means negative, and negative will be plotted up. So this is minus 130, this is minus 160. Now add these two. So join them with a single line. This is a straight line. Now this ordinate. So this common portion will be cancelled. This was overall minus, so this will remain minus. This small will remain minus, and this will remain plus. Right? So the value of this plus will be WL square by 8 means 160 minus average of 130 plus 160 means 95. So this will be 65. Similarly here, this is minus this is 60 and 40, both are negative. Negative will be plot up 60 and 40, and this value will be PL by 4 means 60. So this ordinate overall is 60, and this, since it is in midway, so 60 plus 40 divided by 2. So this is 60 plus 40 divided by 2, 50, and this will be 10. And now add this span. So dear friends, this is the bending moment diagram for an overhang beam. Let us proceed our discussion. Let us take next question. Dear friends, our next question is this. This is also an overhang continuous beam with 3 spans, and fourth is overhang portion. First of all, we will make the correction of overhang, means 20 into 2 means 40 moment will applied here, and here will remain 40, and we'll leave this portion because it's BMD we know. Now our beam is this A, B, C and D, and D is purely hinge. Our discussion will be like this. First of all, we assume all the span AB, BC and CD as fixed, and calculate fixed end moment using WL square by 12 or PL by 8 or PAB divided by L square. So we calculated, for example, in this case, how will we calculate? We will calculate using PAB divided by L square. Moreover, dear friends, sometime in the questions he asked like this. He asked like this. This is the question. Sometime he asked this. This is UDL, and these are 2-point load. This is 10, this is 15. 2 meter, 3 meter, 4 meter. So while calculating fixed end moment, this is 50, this is 10, this is 15. So for example, this is 12, this is 2 meter. Its fixed end moment we can calculate it as WL square divided by 12. So easily. But how we can calculate fixed end moment for this? This is 10, this is 15. Dear friends, we can use principle of superposition. For example, we can take first of all first load. This is 10, this is 2 and this is 7. Similarly, now we can take this is 15 and this is 5 and this is 4. This value will be P A B square divided by L square, and this value will be P A square B divided by L square. Now this value P A B square divided by 4 plus 5 9 square, and this value is 15 into 5 square divided by 4 divided by 9 square. So final answer will be final fixed end moment due to this 10 and 15 will be add these two. For example, this value is x and this value is y. So your answer will be x plus y. Maybe this value z, this value alpha. So your answer will be z plus alpha. So in this manner we can calculate fixed end moment, right? Okay, so we come back to our question. Question was this, right? So we calculated the fixed end moment, but dear friends, this is end D, this is D, this is C, this is C, this is B, this is B, this is A, right? So and C, we have to require some correction at end D, since end D is purely hinge. What are the correction? First of all, we will make at hinge. It is 20. We will this is the 20. Apply 20. We will apply opposite in 20 in opposite direction, right? So this will become hinge. Now we will apply plus 40 in cloak direction. So this will be the final answer. So this end will be 20 20 cancel and 40. Now in this side 20 was there. Due to this 20, half of this will be transferred in the same direction. This is 20 anti-cloak, this 10 will be anti-cloak. Now this is 40 cloak and this is 20 is also half of this 40 is 20. So this will 20 20 cancel and this will be 10. So final fixed end moments are MAB. Anti means minus, cloak means this will be plus, AB BA. BC, anti means minus, CB means plus, CD minus 10 and DC plus 40. DC will be plus 40, right? And if we this, okay, CD is what is this written? CD, M bar CD, and this is DE, sorry, this is DE, D2E. Need not to write this, no need to write this. Okay, now first aim is to calculate distribution factor. Dear friends, this is the far end, this is also far end. There are two intermediate joints which are unbalanced. 53 31 unbalanced, 26 10 unbalanced. So these are two joints B and C. So we have to calculate distribution factor. Joint B BA BC, joint C CB CD. So let us calculate distribution factor. This is actually I have solved the question using two methods. I will later discuss slope deflection method, then I will tell about this. First our aim is to use moment distribution method. So using MDM, you will say two joints are there, one is B, other is C. So from B, BA and BC, and from C, CB and CD, right? So distribution factor for BA, this is BA, B2A far end is fixed, B2C far end is fixed. Answer will be 4 EI by L 4. But C2B far end is fixed, but C2D far end is hidden. So here will be 3 EI by L, here will be 4 EI by L. So I have written as this 4 EI by L, 4 EI by L, 4 EI by L, 3 EI by L. So this is joint B. For joint B, net stiffness this plus this. So distribution factor 1.6 upon this, 2 upon this. So these will 2. Summation, sum of these two will be 1. Now similarly at joint C, CB will 2. CB is 2 EI and CD is 0.7 EI. Okay. So distribution factors are 0.44, 0.55, 0.272, 0.727 and 272. Now proceed. This is write beam in the same manner. What is the manner to writing the beam is, the beam was like this. Look here, the beam was like this. This was A fix, this was B, intermediate, so I have written distribution factor. This is C, again intermediate, I have written distribution factor. This is D, so this is D. Now I will write the fixed end moment, which are the incorrect moment, which I am to correct using the distribution factors and by distributing the moment to the far end or at the joint. So dear friends, the end moments are these. First is this, minus 31.25 plus 31, MBA, M bar AB, M bar BA, M bar BC minus M bar CB plus M bar CD minus 10, M bar DC plus 40, and their distribution factor are in the respective manner. These are 0.44, this and this. So I have written this distribution factor. Now distribute the moment. Dear friends, there are two joints. One is this and other is this, right? So the unbalanced moment at this joint, is minus 53.33 plus 31.25. This is minus 22.08 unbalanced. So we will apply plus 22.08 and its 0.44 times will be here and 0.55 times will be here, right? So this joint will be balanced, right? Similarly we will do same here. 26.66 minus 10 will be 16.66 plus. This is unbalanced. We will apply minus 16.66 and its some part will be here minus and some minus part will be here. So 0.272 into minus 16.66 and 0.272 into minus 16.66. So this is the distribution. Now these two joints has become balanced, right? Because this sum and this sum will be 0, this sum and overall will be 0, right? But as soon as applied this moment, far end half of which this moment will be transferred to far, since far end is fixed. And similarly with respect to B, C is also assumed as fixed end, so half will be transferred here, right? Dear friends, earlier the joint was balanced, but due to this 12.14, due to this joint B, some moment is transferred here, so this is again unbalanced moment, 6.07. Similarly no part will be transferred here as far end is fixed, but half of this will be transferred to the far end, and far end is B is fixed with respect to C, so its half means minus 6.05. Earlier above this this was balanced, but due to this minus 6.05 this is unbalanced. So now at joint B, unbalanced moment is minus 6.05. apply its opposite means 6.05 and its some part here and some part here. Similarly here unbalanced moment is plus 6.07, its opposite minus 6.07 and is some part here, some part here. Similarly now distribution half here, half here, half here, no distribution here as far end is fixed, right? So dear friends, this now again this become unbalanced. Here also we make this balance, but due to this will again imbalance. So this process will continue by the time this transferred moment becomes insignificant. For example, in this step you see this is minus 0.12 and half will be transferred here, but this half is minus 0.06 means for approx 0. So we can say that now this transfer is approx 0, so we can leave this on this line, or some more you can proceed more, right? So this is the procedure to calculate the bending moments and end moments using moment distribution method. Now you see this is simple. Now this is minus 0.22, now it's plus 0.22, some part here, some part here, half here, half here. Unbalance is 1.66, its opposite minus 1.66, some part here, some part here, half here. Again unbalance is minus 0.6, its opposite plus k 6.03 plus 6 point, it's some part here, some part here. Here is plus 6.05, its opposite minus 6.05, it's some part here, some part here, right? Again its half is here, half is here. Unbalance is this, its opposite 0.22, 0.22, some part here, some part here, and its opposite minus 0.165, and some part here, some part here, and distribute like this. Finally when we see that this distribution is nullified and this is also nullified, we can leave it here, but it is said that you leave the this method at the point where there is the distribution, there is the balancing of joint, means this is minus 0.6 balance, it's plus, apply plus 0.06, some part here, some part, leave here. Now no need to distribution, and add these all, add these all, these all, these all, these all, we will get the value minus 24.39, here 44.96, here 45.39. remember these two values should be equal and opposite. Due to approximation these values may differ, but dear friends, you have to write down the single value. Either you will write 44.96 means you can write 45 here, minus 45 here, 16.89 here, 16.8, you can write down 16.89 and 16. Or maybe there may be some error, but I think there is no error in the question. But these two values should be equal and opposite. Now we have calculated these end moments, these end moments. This is minus, plus, minus, plus, minus, plus. Now we can draw BMD. Now we can draw BMD. Look how. This is, first is minus, minus means anti-cloak. Second is plus, plus means cloak. Then minus, then plus, minus, plus, minus. Now we will draw BMD. These two arrow hits below the beam. So minus and minus will be plotted up, and this will be like this. Now again here this is 45.3, this is 16.8, both are minus, and minus will be plotted up. Here 16.8, 40, and here it's we are already known. Now this is a parabolic, this is point, this is point. Dear friends, this, look this G, this value, this is not at midway, so we cannot calculate this value as 45.3 plus 16.8 divided by 2. We will calculate using the method which I have discussed earlier. This value will be 16.8 plus 45.3 minus 16.8 divided by 6 into this 4. So this will be the value. So in this manner you can draw BMD, right? Let us take the next example. Let us analyze this frame. Question is frequent for university examination. Generally question is asked in UPT or other examination like this UPT type exams. See, how will we analyze this frame? Dear friends, there are two types of frames. One is the restrained frame, and second is the unrestrained frame. Restrained frame never sways. Sway means to push in any direction or to fall down in any direction. For example, this, if this is a frame and I apply horizontal load, it will deflect like this. We will see that any joint will go like this. This is called as sway. But if in the same frame, the frame would be like this. Even now, if I applied loading like this, frame will not sway. These are called as restrained frame, means they cannot sway. These frames can be analyzed as same as beam, right? So their analysis can be done as same as beam. So take in this frame, Look, this is fixed support, this is B, this is fixed support, this is loading, this is the overhang portion. Our first aim is 10 into 1.5 means 15. Apply a 15 kilonewton load, a 15 kilonewton meter moment and 10 load here, but due to 10 there is no bending of this member, hence we will say that no need to take this 10 load. Now bending moment of this portion is already known, 15, so it is already known, minus 15. Now we have to draw BMD of this portion. Now we can say that since this is not going anywhere, this is fixed here, this is fixed, and joint B neither going up and down nor going left to right, only it is rotating, so it can be treated as a beam like this. This is B, this is A, this is B, and like this is 12 and 15 kilonewton moment. It can be treated like this. So first aim is to calculate, so you can solve this beam or this frame. Let us solve the frame itself. So first of all, assume these two A and B as fixed. This is A, this is B, this is B, and this is C. So the moment will be like this. This is 3.2, 3.2. Now this is also midpoint, so it will bend the structure like this. Look, like this. So moment will be in opposite like this to make this slope 0. So moments will be like this. So we calculated these. Now we will calculate this is the joint. B joint is unbalanced joint, so because here is 3.2, here is 4.5, so we will calculate distribution factor at joint B. B to A, B to C. Far end is fixed, far end is fixed. 4 EI by L, 4 EI by L. So B to A, B to A, 4 EI by L, EI, 4 EI by L, 4 by 3. Answer will be this and this. So these are two distribution factors. Now we will write them in this 3 by 7 and 4 by 7. This will be 3 by 7 and this will be 4 by 7. Now we will calculate. See, MAB, this is anti-cloak means minus, MBA is cloak means plus, MBC is anti-cloak means minus, MCB is cloak means plus. Right? Now distribute. Dear friends, remember one thing. The sum of these two is, their sum is 3.2 minus 4.5 equal to minus 1.3. So unbalance is minus 1.3. But here, so friends, the net unbalance moment is minus 3.2 minus 4.5. It is minus 1.3. So we should apply plus 1.3 to make it 0, but actually at this joint there is plus, cloak means plus, there is plus 15 moment. So the final moment at this joint should be 15. So how much we should apply? We should first will apply plus 1.3 in order to compensate this, make this 0, and then 15. So net applied moment will be 15.3 plus 1.3 equal to 16.3. So dear friends, so an applied moment at this joint will be 16.3 and plus 16.3, and it's 3 by 7 here and 4 by 7 here. So and now since far end is fixed, far end is fixed, so half value is this side, half value this side, sum, this is this and this and this. Now these two will not be equal and opposite because their sum should be, in the earlier case when there was no external movement, this minus and this plus should be equal and opposite, so such that their sum should be 0. But now these two values should be such that their sum should be 15, and which is there. So our solution is correct. Right? Now draw BMD. How to draw BMD, friends? Look, values are plus means cloak, again plus means cloak, again plus cloak, again plus cloak. All the values are cloak. So we will So like this, this is A, B, this is again B, this is C, and this is D. All the values, A to B is cloak, B to C is cloak, B to C is cloak, C to B is cloak, right? So these all are cloak, but this is 15 anti-cloak. This is already known to us. Now draw BMD. In order to draw BMD, dear, listen, this arrow hits up. Up means plus. Plus will be plotted down. So this will be plotted down. This is plus, right? Now this arrow hits down, means negative. Negative will be plotted up. This value is 10.19. Join them, right? Now we take this as reference phase. We generally take loading phase as reference phase. So this is loading phase, so this is reference phase. Now in this case B to C, loading phase is this, so take this phase reference phase. Now this arrow hit on reference phase means plus. Plus will be plotted opposite to the reference phase, means below. So this will be plus 4.81. Now similarly, this is opposite to reference phase, minus 9.5. Minus means on the reference phase, so this value is on the reference phase, 9.61. Again join them. Now dear all, what is our aim? Our aim is, this is a, it is carrying UDL, so it will be like this, plus these two plus will be add, this will be minus, and this will minus. This is already known, and this again, this carries a point load, so PAB by L means PL by 4, so this will be PL by 4. So these two plus will be added and this minus. If you do not have time, you can leave the question here itself, but our aim is to find out these ordinates. Dear friends, generally in the questions we see that answer should be like this. This is, which is the mistake, like this. We think that this is the UDL and this, so we will calculate this ordinate PQ. If this ordinate PQ is plus, means this is up, but if this PQ is minus, means this parabolic is below. So here I calculated PQ and it became minus, means my diagram was incorrect, so I corrected the diagram as below. This, like this, I make this below. So how we will calculate? We will calculate as, first of all we will calculate this distance. We can calculate this distance, which is 0.11. This is 0.297 into x barabar 10.19 divided by this will be total, I think 4 minus x. So I can calculate this x is 0.11. So this value up to the midpoint, because in the diagram load, this is UDL, this is the UDL, so maximum will be at mid and here maximum will be here. So we will calculate this, means mid ordinate. So mid ordinate of this, we want to calculate mid ordinate. Once we calculate this, now this value is 0.11, this value is 1.89. Now we can say that this is 1.89 and this value is 2, means 3.89. So this value is 2, so this total is 3.89. So I will see this, means in horizontal distance 3.89, vertical is 10.19, means on 1, so so it will be 10.19 upon 3.89. So when I will move distance 1.89, this height will be this into 1.89, right? So this value will be, this is this height, this complete height. Now this height of parabola, this will be WL square by 8, so their difference is minus 0.1, means this is minus, so parabola will be below and this straight line will be up. Similarly here we can calculate we want to calculate this mid ordinate. However, this can be calculated as PL by 8, PL by 4 means 12 into 3 divided by 4, but we want to calculate this value, and this value will be calculated. This is the graph, so we will first calculate this value, means this upon this equal to this upon this. So this value is 1.033, so we can calculate this value is 0.47. So in order to calculate this, I will say that this total on moving distance, this total is 1.967, on moving this distance 1.967, vertical is 9.61, on moving one horizontal, this distance will 9.16 upon 1.967 into on moving this distance, this vertical distance will be 0.467, right, and their difference will be 6.82, means plus, means this is above, this is above. So we can solve like this. So this is the how we can plot BMD. Next question. Dear friends, let us take one question of support settlement. The question was asked in UPTU like exam. So this is important for UPTU. However, the concepts are always important for engineering services and administrative services GATE also. So look, the question. This is the question. A, B, C and D is overhang portion. Question is, analyze the beam if support B settles down by 9 mm. EI is given as 1 into 10 to the power 12 Newton mm square. Since all the distance are given in all the values are given kilonewton and meter, so we will convert this 1 into 10 to the power 12 Newton mm square into kilonewton mm. So Newton into kilonewton 10 to the power minus 3 and mm into meter 10 to the power minus 6, means it will be 10 to the power minus 9. So EI will be 1 into 10 to the power 3 kilonewton meter square. Okay, let's see later on. First aim is, this is the overhang portion. Remove this overhang portion, apply 20 into 1 means 20 cloak moment. Now beam is this and its BMD already known. Its BMD is like this, minus 20 and here 0, this is minus. It will be treated as cantilever beam, right, and we will plot it up above, right. Now this is calculate fix and moment. This is A, this is B, this is B, this is C. Assuming this fix and fix, moment will be like 13.33, 26.67. This is 60, this is 60. But dear all, we have to make a correction, right. First of all, we have to make correction, and also he asked that support B settles down by 9 mm, right. 9 mm means 0.009 meter. Look, how will be the structure? The structure of beam will look like this. See, this was A, support B settles down like this, and this is like this, right. So now we can say that since this is cloak, so moment will be anti-cloak. This is anti-cloak, so moment will be cloak. Their value, its value will be 6 EI delta divided by L square. Its value will be 6 EI delta. It's 6 EI, 6 EI. So calculate for AB. A to B, 6 EI, EI is EI, delta divided by L square, 6 into EI is 1 into 10 to the power 3 Newton meter square into delta is 0.09, 0.00, it will be 9 mm, means this will be 1, 2 and 3, 0.009, it will be 0.009, so it will be 9 to 10 to the power 3, this 0.009, so this will be okay, so it will be like this. So these are values. This is 6 CI delta divided by L square, 6 CI delta divided by L square, this is and this is. Now so we can say that final moments are, this was 13.66 and 6 is in same direction, both will add. 26 was in this but 6 is in this, so net in this direction 26.6 minus 6. Now 60 was in this and 1.5 in this, so these will to deduct, and here 60 was in this and 1.5 in this, so net answer is this 19.66, 20.66, 58.5 and 61.5. But dear friends, this end is hinge, so we will have to correction on this. So first of all, we will, this is 61.5, we will apply opposite, means 61.5, and here already was 58.5, but its half will be this 30.75 will be here. Now this become hinge, but at hinge there is 20 cloak moment, there is 20 cloak, so we will apply 20 here and its half 10 will be here, so net add these all, answer will be 79.25, and there will be 20, and here 20.66, here 19.6. Dear friends, if you have got any problem in during this discussion, if you are watching the videos and you have got any problem or any doubt, you can contact me, you can call me, and I have written my number on this, on these sheets. My number is this. My name is Abhishek Kumar and number is 8909449192. If you have got any query, you can call anytime. Okay, so the final end moments are these. Now distribution factor B2A, B2C, far end is fixed, far end is hinge. Look here, far end B2A, far end is fixed 4EI by L. B2C, now beam is this, not this, far end is hinge, so this is 3EI by L. So these are the values, these are values. Now distribute the moments, distribute the moments. Look how. So moments are like this. This is anti-clock, means minus plus minus plus, minus 19.33. Thereafter this is 20.66. There will be 20. Actually there is a mistake in the question. Here I would write 13.33, but by mistake I wrote here 13.366. So it is 13.33, 13.33 here. So it will be 19.33 here. So the actual value is this 19.33. So the moment first is minus 19.33 and this is cloak, means plus. So this value is minus 19.33, this is plus, anti-cloak means minus, cloak means plus. Now at this joint B, net unbalance is this minus 79 point minus 79.25 plus 20.66, means minus 79.25 and plus 20.66. This value is minus 58.59. unbalance, you will apply plus 58.59 and it's some part here, some part here. Since far end is fixed, half will be transfer here, no moment will transfer here, as this is hinge. Now this is balance, so add this, this and this, so value will be MAB plus, plus, this is plus, this is plus, this is minus, this is plus and this is minus. It was written. Now how to draw its BMD? Let us take how to draw. Dear friends, now you can draw BMD easily, but I am telling you how to draw its BMD. Let's take, for example, values are like this. This is plus, plus means cloak. The difference in values is one is from a moment distribution method and one set is from source deflection. So there will be minor difference. So I am taking some value. So this is plus means cloak, plus means cloak, plus means this is minus anti-cloak, this plus means cloak, this is minus. Now we can draw its BMD like this. See, this is the BMD. So this is plus, means arrow is hitting up, so this is plus, plus will be plotted down, minus will be plotted up. So plus will be plotted down, minus will be plotted up, right? Similarly here both are minus, will be plotted up, this is minus, will be plotted here. Now this is, now again you have to check whether it will like this or it will like this. So first of all you have to calculate this x distance, and thereafter you will calculate this, then only you will calculate this ordinate, and this ordinate will be PL by PAB by L, PAB by L. So this difference is minus, hence this is below, this is below, and the ordinate at F can also be calculated. This will be let's see, this is I think there is some error in the question, is that question was this, means here question was this, means there was UDL, but I have plotted like rect, so this is the error, I have plotted triangular, it should be like this, it should be like this, this and this, like this. So this will be calculated as this value, this ordinate will be WL square by 8 minus this will be it is the midpoint, so it will be sum of these two and average of these, so value can be calculated. So this was the question. Let us take next question. Okay, so next case is symmetrical case. In case of moment distribution method, if our structure is symmetrical in all respects, all respect means in loading is also symmetrical and structure is also symmetrical, then how will we draw BMD? So look friends, how will we draw BMD? Two types of symmetry are there. One is called as Coulomb symmetry and other is called as beam symmetry. Coulomb symmetry means like this. See, for example, this is the case, this is the question, and this is UDL, right? This and this. Now we can say that length are equal, everything is equal, means this symmetry is in Coulomb, this symmetry pass through Coulomb. Or we can say that if beam is like this, this symmetry also passes through support means this is also Coulomb symmetry. In these cases he says that if structure is symmetrical, means if it is A, this is B, C, D, E, F, so structure is symmetrical, means there is this theta C will be 0. We can say that if it is A, it is B, it is C, we will say that theta C will be 0, means if theta C is 0, means in this case he says that this theta, if it is symmetrical, means neither it will bend like this. In earlier case, if loading was not unsymmetrical, if loading was not symmetrical, we would say that either it bend like this or it would bend like this, means this is theta B, this is theta C, or this was theta C. But in this case, since loading is symmetrical, neither this is possible nor this possible, means this theta C will be 0, means it has to fulfill the requirement of both span. This span will say that you will bend like this, this span will say that you will bend like this, means the structure will bend like this, like this. So this we will say that this theta C is 0. So if this theta C is 0, means we can, and it is not going from in leftward, not going up and down, and neither theta C 0 means neither it is rotating, means it can be treated as fixed end. So we will take as this, we will take it like this, this will be the question. Now we will analyze this, and finally we will draw same BMD in this part, for this part also. For example, how we will analyze this? This is W, this is length. First of all, we will calculate fixed end moment. This is W, this is L. So fixed end, for example, let us take this is 12, this is 12, this is 4 meter, this is 4 meter, this is 12. Fixed end moment will be W L square by 12, means this will be 16, and this will also be 16, but far end is hinge. Far end is hinge means we have to make a correction. What is the correction? We will apply the opposite 16, so it will be 0, and it will be 16 plus 8, it will be 24. So this will be 24. Now since it is the single span, no need to moment distribution, because it's single span, whatever is the moment applied, this is the final. So this is the analysis. Now we can draw its BMD. How we can draw its BMD? It is 24. 24 is hitting down. Down means negative. Negative will be plotted up. So it will be 24, it will be 0, and it will minus, and due to W it will be like this, and at mid this height will be WL square by 8, means 12 into 4 square divided by 8, means it will be 24. This height is 24, and this height is 24 plus 0 by 2 means 12, so this height will be 12. So this is the BMD, this is minus. I can plot same BMD here also like this. So this is its BMD. So this is the use of symmetry. This is the use of symmetry. Similarly, I can make use this. I will say that since structure is symmetrical, hence joint C will not rotate. If joint C will not rotate, neither it will go up and down, nor in horizontal direction. So we can say that joint C can be treated as fixed. So we will take it as this, and it will be treated as fixed. Right? Now if this is fixed, if joint C is not rotating and there is no load in this span CF, hence this CF member will not bend, and if CF member will not bend, then bending moment in CF member will be 0. So bending moment in this will be 0. So we can show like this. This is F, this is C. No load is applied and it will not bend. So we can draw BMD of this part only, and this BMD of this part we can easily draw, and same will be reflected for this. If BMD of this is like this, for example like this, same we can plot like this, like this. Let us take an example, right? Or we can also say that this is the left portion, so the right portion will be this. This is cloak, so it will be anti-cloak. This is the analysis of this beam, right? Let us take example. Let's take this example, right? A B C D E F, right? So we see that this is the symmetrical frame in all respect, in loading and also in the support condition and beam conditions or column condition also, mean that is a structural condition. So we can say that only half of the structure can be analyzed. Since column, this is the column symmetry, theta B will be 0, and also there is no bend. If theta B is 0, there is no rotation of joint B, so no bending moment in span BE, right? And also there may be the bending moment due to loading, if there was loading in this span B, but there is no loading in this span B, hence there will no bending moment, so this BE will not bend. So this is, there is no rotation, neither going up down nor going horizontally, so can be treated as horizontal. So this structure can be reduced to this small structure, and the analysis of this structure is too easy. I will take this span AB, this is D, this is A, this is A, and this is B. Fixed end moments will be 0 since there is no loading. Here fixed end moment will be 256. I will calculate distribution factor at joint A to B fixed, A to D fixed, 4EI by L, 4EI by L. Distribution factor will be 0.75 and 0.25. Now I will distribute these moments. Look how. This is 0.75, 0.25. This is 0 minus 20. This is, I will see this 0 0. Anti-cloak means minus, cloak means plus. So it will be 0 0 minus plus. Now at this joint unbalance is minus 256. So we will apply its opposite, means plus 256, and its 75% will be here and 25% will be here, half will be here, half will be here, final will be 3264 minus 3264. Now we draw only for this span. So A to B plus, plus means cloak, this plus, plus means cloak, this minus means anti-cloak, this is plus. Now in this part, and there will no bending moment is this portion, so it will remain as it is. And in this is cloak, anti-cloak, anti-cloak, cloak, cloak, anti-cloak, anti-cloak, this is cloak, this is anti-cloak. Now I can draw BMD. Look how this face is reference face, this is reference, this is reference, this is reference. How? You see, arrow is hitting reference face, means it is plus, and plus will be drawn on opposite to the reference, means here this is plus, here this is opposite to reference means minus, and minus will be plotted on reference. So this is minus 64, add them. Now here both are hitting down, means minus, minus means both will be plotted up. These two are minus, and here this is UDL, so you can calculate this WL square by 8. This is WL square by 8, and it will be summation. This is 64, right? So I can draw the BMD of half portion and half portion. Bending moment in this span will be 0. Okay, let us take next question. Let us take question based on beam symmetry. Look here. Okay, I was discussing the beam symmetry. If this symmetry is in beam, for example, this is the question, this look. Now the structure is symmetrical about this portion, half this and half, means symmetrical is symmetry is in beam. This is called as beam symmetry. In order to calculate BMD or bending moments at ends of this structure, we will say only we will analyze only half of the structure. But he asked that the stiffness will be modified stiffness for the span which you are taking half. For example, one will be this span, so this is joint B, far end is hinge, stiffness will be 4EI by L. Now for this far end is fixed, stiffness will be 4EI by L, but he take, if you are analyzing the half structure, take stiffness as half, means in spite of 4EI by L you take 2EI by L for this. This is A, this is B, this is C, this is D. For BC you will write for joint B, and this is A, so this is BA and this is B. For BA you will write 3EI by L, but for BC you will write 2EI by L. And now only calculate, analyze this half portion, means bending moment here, here, and this portion, this is anti, this will be cloak, this is cloak, this will be anti. Answer, right? So look, one question. This is the question. So this is the frame, this is symmetrical frame. Frame does not sway, means frame is symmetrical in all respects, means there is no possibility of sway. means neither it can go in this direction nor go in this direction, right? So this is the symmetrical loading. I say that since it is symmetry in half, this is the beam symmetry, so I will calculate, for example, joint B. I will take B, so B to A, this is B to A and this is B to C. From B to A, or here you can write B to A and this is B to C. From B to A, far end is fixed, K will be 4 EI by L, means 4 EI is EI and L is 3. But here K is, since far end is fixed, so you should have to take 4 EI by L, but since we will analyze only half structure, so we are taking the modified stiffness, that is 2, and EI is 2 EI and divide by L is 2. So answer is 2 EI, right? So these are the stiffness, 4 by 3 EI and 2 EI. Now we will analyze. See how we will analyze. Our first aim will be to calculate the end moments. First aim will be to calculate the end moments. How we will calculate end moments? See, this structure, this assuming all end as fixed end, now it will be bend like this, so end moment will be like this. It will bend like this, end moment will be like this. It will bend like this, end moment will be like this, right? So I calculated these all, but remember I will consider only half. See, so what is the half part? Let us see here. This is the question. This is A, this is A. See, this is A, this is B, and here will be C. So stiffness are these 0.6 and 0.4, right? So I will analyze this half part only, and the analysis will be like this. Analysis will be like this. This will be end A, this will be B, here C, here D. We need not to write these all things. We will write only A, and A was how much? It was this. MAB was, it was minus 2.22. This is minus 2.22, and BA was plus 4.44. BC was minus 5 and CB was plus 5. We need not to write these things, right? So we will analyze only half part. So this need not to write this. Now analyze this. The unbalance is minus 0.66. So it's apply plus 0.66 and it's 0.4 times here and 0.6 times here. So now half, since far end is fixed, so half will be transferred here, and this side also far end is fixed, but no need to transfer here because we can write this value using this value. So we need not to write these all values, we will write only this value. So this is the complete. So answer will be minus 2.108. Add this, this is the answer. However, you can analyze using general method. These all, if symmetry is also there, you can also analyze general method, but that will be large enough, means lengthy approach. But this is the shortest approach, right? So this is minus means anti-cloak. This is plus means cloak, minus anti-cloak. Now in the remaining half, this is anti, this is cloak, this is cloak, this is anti, this is cloak, this is anti. So these are the final fixed end moment. Now on the basis of these fixed end moments, we can draw BMD. We can draw BMD like this. Look here, we can draw BMD. This leg, this leg, this leg. This is hitting inside. This is reference face, this is reference, this is reference. So this is hitting inside, so it will be minus will be plotted on reference face. This is inside, minus will be plotted on reference face, and this is also hitting inside, minus will be plotting reference, add them, and this is simply supported. Similarly here, this is minus, this is on opposite to reference face, means minus will be plotted up. This is opposite to reference, minus will be plotted up, and this will be this UDL, and half same will be like this. So in this manner we can draw BMD. Let us take next example, close box frame. Actually these questions are from engineering services and IAS and GATE exams. So this it has highly scope. So let us solve some more questions. However, UP2 is